In this video, I'll explain what is homogeneous function. A function u equal to f of x comma y is said to be homogeneous function of x and y of degree n if it can be expressed in the form u equal to x power n into f of y by x, a new function in terms of y by x, or u equal to y power n into f of x by y. Here you will get a function in terms of x by y. Then we call such a function as homogeneous function. One more way to prove the function is homogeneous, if you have u equal to f of x comma y, then you have to replace x by lambda x and y by lambda y. Then if you could write the given function as u equal to lambda power n into f of x comma y, then we call that function as homogeneous function of degree n. Replace x by lambda x and y by lambda y. So in case if you can write it as the same function as lambda power n into f of x comma y, lambda power n into the given function itself, then we call such function as a homogeneous function. Say for example, here u equal to x power 4 plus y power 4 divided by x minus y. See, we can write it in this form, that is x power 4 when you take common 1 plus y by x whole power 4 divided by, here x common in the denominator, 1 minus y by x. Now you see here x 1x cancels, so you'll get x cube into, so here 1 plus y by x to the power 4 divided by 1 minus y by x. You can see this is x cube into f of capital F of y by x. This is a function in terms of y by x. Therefore, this is homogeneous function of degree 3 in x and y. That is because here x cube is outside f of y by x. One more way of checking is it homogeneous or not is replace x by lambda x, y by lambda y. Now I can replace x by lambda x power 4 plus lambda y power 4 divided by lambda x minus lambda y. So that is equal to lambda power 4 common, x power 4 plus y power 4 divided by lambda into x minus y. 1 of lambda cancels. This is lambda cube into x power 4 plus y power 4 divided by x minus y is the given function u itself, that is u of x comma y. Therefore, u of lambda x comma lambda y, I got it as lambda power 3 into u of x comma y. Hence, this function is homogeneous function in x and y of degree 3. This is by replacing x by lambda x and y by lambda y. You can check this as homogeneous by taking y power 4 common as well. That is, if you take y power 4 common, you will get x by y power 4 plus 1 divided by y into x by y minus 1. So you will get a function y cube into, you will get a function of x by y. Here are two examples. Verify which of the following functions are homogeneous. The first one, u equal to sine inverse y by x plus tan inverse x by y. So you can replace x by lambda x and y by lambda y. So you will get sine inverse of lambda y by lambda x plus tan inverse of lambda x by lambda y. So anyway, lambda cancels. You will get the same function back, sine inverse y by x plus tan inverse x by y. That is lambda power 0 into f of x comma y. Here in this case it is u. So u of x comma y. Therefore, this function is homogeneous function and it is of degree 0 because you got lambda power 0 into u of x comma y. Similarly, second one, in this case u equal to, either you can replace it by lambda x lambda y, that is the best method. So here in this case, if you take x power 4 common, 1 plus y by x whole power 4 divided by root x common, then 1 minus root y by root x. So that gives you x power 4 minus x power 1 by 2, that is x to the power 7 by 2 into, it is a function of f of y by x. Therefore, this function is homogeneous and it is of degree 7 by 2. If you have functions more than two variables, in that case also same method is applied to check whether the given function is homogeneous or not.